Welcome to the NPTEL certification course named Characterization of Polymers, Elastomers and Composites. In fact, this time it is the third rerun of the course. And I belong to Indian Institute of Technology, Kharagpur, which is the oldest IIT amongst all IIT. And I have been working here for last 22 years approximately, and where I am doing teaching and active research here. So, I belong to Rubber Technology Center. Okay. So, IIT Kharagpur was established in 1951, and precisely from that time onwards rubber technology was there in the Department of Applied Chemistry. So, eventually it has emerged in 1981 as a separate independent center, and that is unique in the country, unique amongst the all IITs. Okay. So, we have a very rich history about rubber research, rubber teaching in the country. Okay. So, about my research group, it has certain agendas. We call it a space group, okay. And it consists of structure property relationship of polymers, smart and stimuli responsive composites. We covered viscoelasticity behavior of polymers and polymer blends. Of course, viscoelasticity is very closely connected with the polymer processing and rheology, that also we cover. We do cover life prediction of polymer products, biomaterials and soft materials in healthcare applications. Okay. About 31 PhD students graduated so far, working in the same group, and more than 70 master students. Okay. If you look at our civilization, it is named after the material it discovered. Okay. It starts from the Stone Age, then the Metal Age, then Polymer Age, and now very precisely it is a Composite Age. So, any material mankind discovers or utilizes for the civilization, okay, has to be characterized precisely. Unless you characterize it precisely, you will not be able to do the modification and advancements. Okay. So, characterization is part and parcel to that, and every now and then there are more and more precision, more and more development in the area of characterization. And not only that, today many of the soft material, including rubber, mostly in rubber, and of course in plastics and fiber textiles, there you have certain sort of ingredients are almost like restricted or banned. Okay. And those are called substances of very high concern that can actually pollute our environment. Okay. So, even a parts per million ppb level of those ingredients are hazardous. Okay. So, a more precise and more quantitative characterization plays utmost important role. As I said, this characterization course is 12-week, and we precisely put them in 12 different main titles, and then we have 5 lectures in each week embedded. So, the first one is of course the introduction, and one of the very basic thing one must understand is the structure property correlationship of in a soft material that includes polymer, elastomers, fibers as well as the composites. Okay. Then again we vividly given it over 2 weeks, week 1 and 2 we have given it in a detailed and thorough correlation between them. And then number 3 was a chemical method of identification, that is probably the cheapest. Okay. Even if you do not have a sophisticated instrument in your laboratory or in your concern, you still can characterize them. How to do that? Okay. Now, then we have introduced you to certain standards. It can be international standard, it can be national standard, it can be of company standard, organizational standard. Then we briefly went into the UV visible or spectroscopic characterization rather, and then infrared, okay, and that encompasses blends, polymer modification, compatibilization, coupling, and many of the facets of polymer applications, and including rubber. Okay. And then we have taken you to photoacoustic spectroscopy, Raman spectroscopy, atomic absorption spectroscopy, and electron spin resonance spectroscopy (ESR). So, up to 6th week we are going through the thorough characterization of that. Again, 7th is also characterization, spectroscopic characterization, which is none other than NMR, and very in depth we have given a principles, fundamentals and application of NMR, and that includes solid state NMR as well. Week 8 was on thermal analysis technique, that includes DSC, TGA, DMA and etc. And then week 9 was on X-rays, so XRD, XPS, which is a surface characterization of course, and then XRF and the principles, fundamental, and everywhere we have tried to correlate it with the final application. So that way it will be more like applied sort of a characterization techniques that we apply ultimately. Week 10 onwards, we shifted our notion towards the microscopy, and we started with optical microscopy, which is the mother of all microscopic technique, then eventually taken you through AFM and finally to the electron microscopic technique. Okay. And then week 11 was more of the application. Okay. So, unless you apply it, as I said, it does not have any meaning. Okay. So, it has the notion was a not only the R&D, but also in industrial application. Then we taken it through the chromatographic technique, more advanced technique, DETA, which is a dielectric technique, then quantification of rate dependent methods, say crystallization, say degradation, etc. And most importantly, what we covered, the reverse engineering. Once you have a product, you have no clue what it is made of. There may be 10, 15 different ingredients. How to very precisely, qualitatively and quantitatively estimate what is the formulation is all about. Okay, it's interesting. And then we have taken you through other facets where the advancement is coming. As I said, the advancement is a very continuous process. Okay. So, who are the audiences? Of course, you may be wondering. It includes up to 3rd to 4th year undergraduate students, 1st and 2nd year postgraduate, and PhD students. I am talking about the regular students and the qualification. Okay. And subject domain, I mean specialization in the undergraduate or even before. It can be polymer science and technology, it can be rubber technology, it can be plastic engineering, industrial chemistry, applied chemistry, metallurgical engineering and material science as such, ceramic and science and technology, nanotechnology, pharma, and for the industry learner, they can be from any places. They can be from R&D mostly, quality, and also from the production, because production people also they have to know what exactly they are making, because product is no other than a material, it is made of the material. Okay. So, there also we envisage that application will be there. Okay. So, some of the companies by now you might have understood who are the beneficiaries. It can be some industries like with whom we at least have a gross interaction here, cross talk, like Reliance, Tata, IRMRA, okay, which is Seat, Goodyear, all the tire manufacturing industries, Apollo, Yokohama, even the JK tires. So, all tire industries, I mean multinationals are no exception to that. I could not name everybody there, every tire industries here, but in general all the tire industries, all the rubber allied industries, conveyor belt industries, okay, belting industries, hose industries, and of course, the paints and adhesives like Pidilite, Axonable, Berger paints, Asian paints, carbon black manufacturing, silica manufacturing industry, carbon black including Aditya Birla, Philips carbon black, or Madhu Silica, etc., who manufacture silica, Evonik, Momentive, Sabic, Saint Gobain's, even the big players, big giant players, I mean of polymer industries who manufactures polymers, okay, and of course, the additive industries. Okay. So, one of the important feature of this course that it gives you a practical demonstration, even though it is an online certification course, but still we try to make it as much practical as possible. In that essence, we have given introduction to chemical analysis that in a hands-on way, and then universal testing machines, UTM, UV visible, FTIR, DSC, TGA, DMA, optical microscope, AFM, and most importantly, we try to introduce how to play with the images, how to quantify the images, like some of the free OS like ImageJ is available, how to better utilize it to have a quantitative interpretation of photo microscopic images. Okay. So, a picture says 1,000 words. Unless you really able to interpret it quantitatively, it does not make any scientific or quantitative sense. Okay. So, there are many of the students who are actually instrumental in the foundation of the course, okay, but in the respective way I have acknowledged them. So, here in this particular course there are two TAs. One is of course Romita. Romita was from the very beginning as a TA along with Devabruto, Abhijit, as well as Apurna. Okay. And eventually now Nikhil is since last year he is also inducted as a TA. So, two TAs, I am really grateful to them to help me time to time and again in different forms. Okay. finally, to conclude, if you look at the statistics of the course in the previous years, and before that even, the course is a 3 credit course actually, and as I said, it's a 12 weeks, so 12 into 5, so 60 lectures roughly about. And if you look at 22 to 24, so far the students or learners attended is 4,862. If you go to the final split of it in 2022, when the course was commenced in, was 1,747 attended. Then the first rerun was attended by 2023 1,596. Second rerun, there are altogether 1,519 students enrolled, and this time in the third rerun I would like to see it in more numbers and more flying colors, because this course, if you look at, has a very high feedback, high rated feedback. So I would like to see make sure this time is going to be way past 1,700, more than the first time. Okay. With that, thank you very much, and welcome to this third rerun of the NPTEL courses on characterization. Thank you.